Hey everybody, if you failed the HTML compression test, have no fear. It's not rocket science to set up. In fact, it's as simple as can be. And it may very well help improve the page load time of your website, thereby improving user experience, and from there help you climb up the search engine rankings. If you've got a gigantic site that requires a lot of bandwidth to serve, this is one easy way to reduce server costs. But even for smaller websites, it does make a significant difference in page size. It's one of the easiest ways to optimize your site, so really there are no good excuses not to do it. So, what is it exactly? HTML compression is a technique that we all know from archiving files and directories with archive compression programs like WinZip, WinRAR, 7-Zip, and others. What HTML compression does, basically, is it takes your HTML code, looks for similar strings within it, and replaces them with shorter strings, resulting in less code and therefore smaller file size. Note that this is not the same thing as minification, though that's a fine method as well if that's what you're into. Minification is the process of eliminating all the spaces, the line breaks, empty lines, indentation, and so on within your code that makes it easier for humans to read and work with. Non-humans don't need all these buffers to visualize the contents of the code. So with minification, we can trim all that fat, which results in a slightly smaller file size. That's well and good, and yes, this will translate into less bandwidth requirements to deliver your code from a server and deliver it to someone's browser. But compression goes that one step further. It searches for similar strings like I just mentioned, and replaces them with shorter references, resulting in much less code. For example, let's say I've got all these closing div tags after a certain section on my web page. There's 12 of these, the greater than and less than signs, the slashes, the Ds, the Is, the Vs. Now don't worry, this is not something you have to do manually, so don't get rattled here. I'm just showing you how the process works. Minification would do this, but compression would look at that and say, actually, instead of seeing this as 72 characters, let's look at this as 6 characters repeated 12 times. We've got these first 6 characters, the greater than sign, the slash, div, and the less than sign. We'll keep these as our reference, and make a second reference to the first symbol, starting 6 characters back. And we'll say let's use the next 6 characters from there. So now we've got our first closing div and our second closing div. Since the next 10 closing divs are the exact same, we can make this refer to the next 60 characters. And voila, what started as 72 characters uncompressed in their original form can now be represented by just 14 characters in total compressed format. So that's the basic idea. If we apply this to our entire page with all the div tags and all the tags like body, paragraph, images, lines, and so on, as well as hrefs, all our style classes, and so on, our uncompressed web page that clocks in at 167 megabytes comes down to a lean and mean 78 megabytes once compressed, a whopping 46% reduction in file size. Rock and roll. Then when a user requests our content, our server sends that smaller, compressed code. The user receives it, their browser decompresses it, and boom, they've got our content. So yeah, this last action does take time and CPU, but in almost all cases it takes much less time than transferring your HTML content in the larger, uncompressed format. So that's how it works. Again, don't lose sleep over these details. You don't need to mess with your code or know how to write algorithms to make this work. All that's taken care of. The most common HTML compression methods are deflate and gzip. And honestly, there's not a gigantic difference between them. They both use the same compression method, the same algorithms, but gzip also contains a checksum and a header footer. So deflate is technically faster, though you also technically risk broken payloads since there's no checksum. Anyway, go ahead and research this more if you feel like it's worth your time. But in my opinion, tomato tomato. In my case, I use gzip because it's good enough, and it errs on the side of safety in terms of delivering content. Now, to implement either of them is pretty simple. It just depends on what kind of server you're running, or if you have an htaccess file. If you've got an htaccess file, simply edit it, and add these deflate codes to it. Or for gzip, add these gzip codes. Save, and done. Kick back, crack those knuckles, and lace your hands behind your head. Your HTML is now compressed, and users requesting your content will automatically receive that compressed content, which will decompress in their browsers. If you're running on Nginx, you'll want to edit your Nginx config file. Add the following, save, close, and restart the server. And on Windows servers, it's even easier. You can just open up your IIS Manager, click on the site in question, click Compression, and enable Static Compression. And for WordPress users, it's still best to edit your htaccess file directly like I showed you a minute ago. But WordPress also has a built-in gzip compression in your options, which leverages PHP. Again, it's better to do it through your htaccess file, but hey, if that's just too daunting for some reason, then this method also works. And when you're done, assuming you went with gzip, you can Google gzip compression tool and test your web pages to make sure it's working. Feel free to check out our other videos so you can keep fine-tuning and getting the most out of your SEO. And click subscribe to stay updated with new tips and tricks to get you to the top of the search engine results pages.